All right, so here's another demo that's going to seem like magic, but it's just physics. So I have a wood meter stick here, and it's on something that can swivel. All right, and what I'm going to do is move that thing without even touching it. All right, just like Star Wars. All right, and how I'm going to do that, I'm going to use our familiar negative rod. All right, and let's see what happens. All right, notice I'm not touching this thing, but I can make that thing swivel around pretty easily, all right, without even touching it. So you want to say, well, yeah, no doubt, charges can attract other charges, but you wouldn't necessarily think of wood as being a conductor. It's not a very good conductor. And if that's the case, even I can attract this thing with this without even touching it, just like I'm Luke Skywalker. All right, pretty awesome. Well, maybe saying, well, okay, well, it's easy physics. That thing is attracted, opposite charge attract. So if this is a negative, you would think that would be a positive. All right, well, we can test that very easily by doing a positive charge. All right, and if that thing was attracted to a negative, it should be repelled by a positive. Well, let's see what happens. Notice it's attracting. How can it be attracted to both? Well, it's pretty wild. And again, notice I'm not touching it. I can pull that thing. Pretty wild. So I'm going to show you another demo that's pretty interesting as well. All right, and then we'll go over the idea of how this actually works. How can it be attracted to both things? All right, so let's see this other quick demo here. Okay, so here we have water coming out of the faucet, and you would never think of water having a charge. All right, you never put your hands underneath and go to wash your hands and worried about getting shocked necessarily. So you don't think of it as of having a charge, as being neutral. Well, let's see what happens if I bring our negatively charged rod near it. Let's see what happens. Notice that the water bends. Can you see that? That it bends towards. I can bend the water without touching it. It's attracted to the do a little bit lesser. It's attracted to the negative charge. All right, probably gonna make this one bend even more. Look at that. All right, that's pretty wild that I can bend water. You've never thought anybody could ever do that, but it's like magic. All right, so you would think that that water is some messed up water that's got a negative charge, or sorry, a positive charge, because it's attracted to the negative. Well, let's see. All right, I can confirm that by bringing a positive charge near it, and if that thing is positive, then it should be repelled. Well, let's see what happens. Nope, it's still attracted towards it. All right, how can something be attracted to both positive and negative? All right, can bend water without touching it. So that's the question, how it should either be repelled or attracted, not both. So how does that work? Okay, so some of you might know the answer from chemistry, all right, on why that water is attracted to both. So we take water, which is, we all know is H2O, which means it has two hydrogens per 1 part oxygen. Now the way it's structured, all right, and I'm thinking back to chemistry, which has been a long time. So if I get something wrong here, don't grill me. I'm not a chemistry geek, but the idea is that the oxygen shares its electrons with the hydrogen. All right, so the hydrogen is sharing this electron, leaving the hydrogen nucleus exposed. Well, what's in the nucleus? A proton. So essentially, both of these hydrogen atoms essentially become your positive parts of the whole molecule. All right. Now, the way the thing is structured, all right, you can imagine like this is the whole water molecule here, not just the oxygen, the whole water molecule. You can have the two positives, which is the hydrogen parts, and if you have the two positives there, that exposes another side that's negative. Now, water is a polar molecule, which means these hydrogens are kind of allowed to move wherever they need to in that molecule. They still stay attached, but they're allowed to move. So what happens is If I bring a negative rod near the water molecule, well, the hydrogen parts, which are positive, are going to be attracted to this and are going to go over there, and that whole entire molecule is then going to move towards it, so it stays attracted. Likewise, if I switch it over to positive, then the hydrogens are going to go to the other side of the atom, exposing the negative, and then the negative of the molecule is going to be attracted to positive. And that's why both sides, that's why in both cases it's attracted. It's not magic. Magic doesn't exist, unfortunately. It's just physics. So your physicists are essentially the real magicians out there. So that's your little lesson on what we call charge polarization. And it's another cool demo of bending water, which is kind of interesting. Hope you enjoyed. Hope you never seen that before. And now you know, and knowing's half the battle. So see you when I see you.